Okay, so this is an intermediate level question. It tells us that you want to retire as a millionaire. You want to retire in 40 years. You can earn 12% annually on your investments. And it asks us, if you want to have $1 million in 40 years, how much do you have to save each month? And then there are some variations of the question. So if you wait for 10 years before you start investing, and if you wait for 20 years to start investing. So to start solving the question, we need to recall the basic future value of annuity formula, which is equal to the cash flow times 1 plus R to the power T minus 1 divided by R. So now that we have the basic equation, we can start solving the question. We know that you want to be a millionaire, so that's your future value of the annuity, 1 million. So we're going to set the FVA as 1. Now the question asks you to calculate how much you have to save each month, but you know that the rate is 12% on an annual basis, so you have to bring these terms into the same line. So really you're not earning 12% annually. You want to bring that to your monthly terms. So you have your R, and you want to divide that by 12 because you have 12 months in 1 year. And finally, because you're saving each month but you have your annual rate is given to you, your time period is going to be 12 times the 40 because there are 12 months and 40 years. So T is going to be 480. So now that you have all the terms in the same alignment, you can really substitute the terms in and calculate the cash flows. So for the first part of the question, we have 40 years, 12% annually, and how much do you want to save each month? So you have the value of $1 million is equal to some sort of cash flow multiplied by 1 plus 0.12 divided by 12 to the power of 480 minus 1 divided by 0.12. And once you solve this equation, you know that your cash flow is equal to $85. So if you were to invest for 40 years at 12% annually, you'd have to save $85 each month to reach $1 million once you retire. So the second part of the question is, well, what if you wait for 10 years? Well, the effect is really reducing the number of time periods for which you're compounding your annuity. So your new time period becomes 30 years times 12, because you want to calculate it in months. You're really looking for monthly cash flows, not yearly. So it's going to be 360. Once you have your new time period, you can again calculate your monthly cash flows by using the future value of annuity formula. So you have 1 million is equal to cash plus 12 divided by 12. So here your interest rate stays the same at 12%. It doesn't really change throughout the question, but you do have to divide it by 12 because you want to bring it to monthly terms. Divided by 12. And once you solve this question, you get a value of $286.13. So if you wanted to be a millionaire, but you wanted to wait 10 years until you started investing into your 12% investment, you would have to save $286 each month to get to $1 million in 30 years. And finally, the last part of the question is, well, what if you wait for 20 years? Again, that only affects your time period, so your T becomes 20 times 12, because that's your number of months in 1 year, so 240. And now that you have your time period, you can again solve for the cash flow. we have a million is equal to C again, your interest rates don't change, they just have to be divided by 12 because they're given to us in annual terms. And we calculate that the annual or the monthly cash flow is $1,010.86. So if you wanted to be a millionaire, but you only invested for 20 years and you earn 12% per year, you would have to deposit $1,010.86 each month to reach $1 million in 20 years.